Right. Another ternary blend concrete you're going to learn about now, but we're not talking about a macro project, a huge project. We're talking about a micro project here. It does have a tall tower on the top, but nothing like a spire. And I'm sure there's lots of people who are going to argue the point as to what is the tallest building and whether it's to the top of the building or the top of the spire, because I know that's been a big argument with Willis Tower for a long time. Great Stupa of Dharmakaya. Again, this was not one of my projects, but it's one of the projects that I've heard about and I talked with my colleagues about who were involved. And it's one of those projects that actually comes back to where we were doing the basics of concrete technology and actually using what we knew to work in bits of paper and everything else, no computer programs, to actually design the concrete to achieve what they wanted it to. And the question was asked in 1988, any design consultants in? Concrete consultants, design consultants in? No, good, we can insult them. What would you say if someone said, I want a concrete to last 1,000 years. Will you give me a concrete to last 1,000 years? Yeah? No, there's a few head shakes there. No. Some of them, so I'll sign off on that. That's 1,000 years. There are people who would think about that and say, oh, let's actually look at that. Let's actually think about that design, because that was the question that was asked. We want to build this thing and we want it to last 1,000 years. And, you know, we're talking about 200, 300 years now with a lot of the projects that we're doing now. But this was 1988. This was pre-Life 365 and all of those sort of things. So the first thing they said was, what's a stupa? And a stupa is a spiritually empowered monument. It's a religious building. It's a place of worship, but it's also somewhere that you look at. As it says there, it liberates on seeing. It's something when you look at, you feel a sense of peace. It looks nice. It looks pretty. It calms you down. And as you can see, this was built to honor the founder of the Shambhala Mountain Center. And you've got a little picture of the stupa at the end because they obviously tell you that this is where it is. And it's that sort of thing that we're talking about. And they said, right, okay, yeah, now we know what it is and what it's roughly going to look like. We can start talking about what we're going to do with this. And then the guy said, yeah, but we've got to think about this concrete because the location is at Red Feather Lakes. And I think I've got a laser on here. Red Feather Lakes, maybe not, there we go. Red Feather Lakes is there, right up there. There's Fort Collins, there's Laramie and Cheyenne. And they said the nearest ready-mix producer is in Fort Collins. That's right, it's an hour's drive away. And that's to the bottom of the mountain, not to the top. Because it's actually at 8,500 feet elevation. So it's probably taller than K118, but it's just a little bit shorter in the thing. But, so we've got to get it there. And don't forget, we'd like the concrete to last 1,000 years, actually, when it's got there. Slight difficulty, it's not going to be one of those pours where we start on a Monday and we pour one section and then next week we pour the next section. 3 weeks later, we've finished pouring the concrete. It's going to be built by volunteers and it may take some time, like years. It's not a huge project, but it's going to take some time to build. So, okay, we've got to think about this because there's a number of things to look at on there. As we say, I'm not getting at Denver and Colorado or anywhere like that, but yes, in winter, it's naff. Yeah, it's difficult to get the concrete around. There's not a lot of roadway when you get there. Access is a little bit difficult. You know, there's little bridges for the people to go across and a wheelbarrow maybe, but you're not going to get a concrete truck over there. But it's a very nice place when you get up to the mountain retreat. Nice place. So we've got to think about all of these factors as we put this concrete together. And it's one of those things is working as a team. You've got to think about who's going to be placing it, how they're going to place it, how long it's got to get there. All of these sort of things, they started putting that together. Started thinking, well, what sort of strength are you going to want? And it's not high strength, but it is high performance. And this is one of those key factors that we look at. we're going to talk about 6,000 PSI at 28 days. They decided on that. They actually started off at 4,000 PSI, and they thought, well, if it's going to last 100 years, we ought to just jack it up a little bit and make it 6,000 PSI. Going to want air in training. It is going to be up in the mountains. There is going to be some cold effect. There's maybe some freeze thaw, not as much as you would expect down on ground level during winter, but there will be some. So we'll entrain the air. And, oh, don't forget, we want it to last 1,000 years. It's got to be a durable concrete. Now, most people at that point in time just said, no, we'll walk away from this. We're not getting involved with 1,000 years. But there was a guy by the name of John Luciano at Master Builders Technologies, and he got a few programs that he put together, a few equations that he put together, and he started work on it. And they added a few more thoughts to this, of course, because it's going to take some time for the truck to get there, about an hour. So the concrete's got to be live for about an hour to get there. They're going to then manhandle it up the mountain. So we want this concrete to be live for another couple of hours when it actually gets there, because they've got to get it up the mountain, then they've got to place it and pour it and everything else. They're going to pour some big blocks. So we're going to have to think about that, because they're going to pour some concrete and then they're going to stop. So they're going to have to make those joints work really well. Also, we're going to want a really creamy mix, because there's some very nice facades and very delicate fascias that are going to be put on this building, and they want to make that as well. So it's going to be a complicated mix when they put it together. What about that air? Because you've now got concrete that has been running for over maybe 2.5, 3 hours, and you want to keep that air in there to make sure that it's going to maintain that freeze thaw resistance. We know that you manhandle the concrete with air in it, eventually it runs out the air. So within that time frame, they wanted to be sure of that. So what they did was they looked at a few things, and they said, what we want to do with the concrete to start with is we're going to put a load of Class C fly ash in there. You've just seen a slag ternary blend. This is a fly ash ternary blend. We're going to put a lot of C fly ash in there to give it that long-term strength, because obviously they're going to keep the temperature down and the reactive rate down with that fly ash as they're producing it and getting it there. They then want it to seal up and gain strength. So that's where the silica fume comes in to give it the kick on that mix. They're going to get enhanced durability with the silica fume as well. It's going to seal it up, because this concrete is possibly going to be exposed to the elements in between times. It's going to take a long time to build. And the triple blend, that fly ash and the silica fume working together, the synergy of those products is going to give you a nice fine mix, which should give them a fine paste to give that dense surface and that very fine fascia. What about the air? What are they going to do about that air? Because remember, this is pre-PCEs, this is pre all those other types. Just at that point in time, MB had come up with the first synthetic air entrainer, micro air. And this was working very well in all their experiments. And I thought, well, for a religious building, we're going to give the micro air a baptism of fire. We're going to try to use this and see how well it works in that situation. Their target for 100% freeze thaw in that situation was 300 cycles. So 300 freeze thaw cycles. What they achieved was over 500 cycles with this mix. And of course, you have to remember, as I said, once it's fairly cold up there, it stays fairly cold. There's not going to be a lot of cyclic running. There will be some, but they worked on the fact that if they could get 100% freeze thaw, 300 cycles, this would be the sort of concrete they needed. So that was the design. That was what they came up with eventually with the design. And you've got everything here. It's not quite as technical as Stephen's slides for you there, but we have the essential bits and pieces. So it wasn't a huge concrete mix. You can see we're up in the region of that 800, 900. So we're in roughly the same sort of area in terms of total cementitious pounds per cubic yard. The aggregates were added to yield. Now, we haven't got the numbers, I haven't got the numbers, but to yield to give the rheology and workability and placeability of that concrete. Good amount of high range water reducer, best they had on the market. And 0.35 water cement ratio. It's not a high water cement ratio. It's not a low one. It's a nice medium one to give them the results. And you can see at 7 days, they achieved the 28-day strength. So they're quite happy with that. They were going to get that strength, that inherent durability at around 7 days. So they knew they could basically leave the concrete and then come back in a couple of months later and start the next bit and work on that. So they were getting the numbers they wanted, then they had to build it. We're all thinking about carbon footprint and low carbon concrete. And please, will somebody tell me what the term low carbon concrete means? Everybody bans this word, this triple around. They say, we want low carbon concrete. Nobody puts a number on it. So what is a low carbon concrete? Is a 500 kilo CO2 concrete a low carbon concrete? Is 600? Is 400? Is 300? And as we've seen from the first presentation, it's not necessarily the lowest possible mix that gives you the best overall result in the situation. If you can produce a high strength mix, reduces your steel, reduces your volume of concrete, it will reduce the carbon footprint you have. So in actual fact, you could use a higher strength mix with a higher carbon footprint, but you use less volume of concrete and get a lower carbon footprint overall. And this is one of the things that we've got to look at when we're planning these things out. Remember, this wasn't done in 1988, so I did the calculation to see, and you can see, there's your pure OPC. If they did it as pure OPC, it would be around that sort of number. OPC, fly ash, and silica fume still gave them the lowest carbon mix.
OPC? OPC? Can you?
Ordinary Portland cement. Standard, yeah, type 1. Type 1. Sorry, English, so I talk in English. So the triple blend still gave the lowest carbon footprint. So not only is this a high durability concrete, it's low carbon as well. As I said, there was going to be some big pours. There was going to be some big pours because this is a building. This is a worship room in here as well. So they wanted it to be good. They wanted it to be solid. As you can see, very simplistic. As I said, it was built with manual labor. So it's very simplistic, very straightforward, very square, very solid, very straight. And you can see that it's been built in sections because you can see the pattern in the lines. You can see where some of the cold joints came in and that sort of thing. But it was built very, very solidly, very determinedly to make sure that it did the job and would last. You can see up on the mountain just behind, you can see all the snow. So you know it's in that sort of a cold region. So this is why they took the care with doing it. Inside, you can see those smooth edges, very sharp lines on that concrete, very good surface on that concrete. As I said, that was the triple blend. That's going to give them that paste in there to give them that finish. Windows and everything else going in. You can see some of the lines up there where just in this bottom corner, you can see where there were obviously joints and they had to make sure those were sealed properly, but very solid construction. And when you consider this concrete might have been around for about 3 hours before they started pouring it into the molds, that's not a bad finish for a hand cast concrete after manual labor to get it up there. There's a few blowholes in there that you'd expect, but there's a very, very good finish to that concrete, a very high quality finish. What you'd expect if you were building something of a building that is going to have a significance to the people. As I said, it's not a huge building, but it has a very high significance to the faith that are building it. And that was what I meant by a detailed fascia. So this detailed fascia is being built up there, 8,500 feet up. After 3 hours, they're pouring this concrete and they're still achieving this quality of finish. Very, very highly detailed finish. And I've even got a close-up for you on the lion. There you can see the lion. There you can even see the curls in the top of the lion's mane. The curls in the lion's mane. That's a really good finish to get on that concrete. And that's the sort of thing that they were after to make this a beautiful structure. Right? This isn't a huge structure, but it's a beautiful structure. And of course, they weren't going to leave the concrete exposed. The concrete has been painted and coated to seal it. And you can see that it's a very, very good finish that they've got on there. Very smooth, very resistant to weathering finish. You can see some of the decoration that is now going into this building. This is built with care. This has been built with love and desire that it will last 1,000 years. And there you can see, there's the spire on the top of this building. But you can see it's a fabulous looking building. It really is nice. It took 15 years. 15 years of manual labor to work on that and to get that building finished. And that's what they achieved with it. And you can see there's the entranceway, so you can go in. There's a worship room inside there, but it is beautiful just to stand and look at. Yeah, it gives you a likeness of being upon seeing it. So it is a fabulous building, and it will last 1,000 years. Let's hope so. These are Buddhists, so they will come back and they will let you know if it doesn't. Beautiful building. This is what we can do with concrete. Doesn't have to be a huge project, but if we do it right and we design it right, even the small projects can be fabulous. Thank you.